Hi, and welcome to this module. My name is Logan Hotchkiss. I'm a member of Green Labs Austria, and today, in collaboration with the newly founded Sustainable European Laboratories, I'm going to be talking to you about tackling the plastic problem in the lab. So to give you a quick overview about what we will be talking about in the next few minutes, we'll first start off with an introduction of why we think this is an important topic to discuss. We'll then move into some of the background research about plastic in the laboratory, followed by implementation of recycling plastic in the lab, and we'll end with some concluding remarks on the entire process. So to get started with the introduction, I think it's very evident in today's world, if you look at the different news articles online or in the newspapers, that we have a lot of environmental issues that we need to address. And so this can be anything from the rising carbon dioxide levels to the wildfires that we see around the globe, and of course, the vast amounts of plastic that are being deposited not only on land, but also in the oceans. And so I think a lot of people would agree that these are very pressing issues. But what is less intuitive is what is the environmental impact of the laboratories that a lot of us consistently work in. And specifically, what we want to talk about today is the waste that these laboratories produce. So to give you an idea of what we're talking about here, we can refer to an article that came out in 2015. And this article did some background research into the plastic generated from a specific bioscience department. And they found that out of 280 bench scientists, they produced approximately 267 tons of plastic in 2014. And this is the equivalent of about 5.7 million empty 2-liter plastic bottles. Now, these numbers sound very, very high, but we also have to remember that this is one department in one university. And if we start extrapolating these values to multiple departments and multiple universities throughout the world, we can see that these numbers will add up very, very quickly. And while these numbers are kind of daunting, we also want to try to put this into something that we can recognize a bit more. So within Green Labs Austria, we actually did an internal study that I'll talk more about later. And based on this study, we found that the average resource usage per microbiology lab per year is about 13 times as high for plastic as it would be for the average Austrian household. And now within this figure, we also have a comparative analysis for the energy, but what we're focusing on today is the plastic. And so from this, we think that there is a problem, and this is worth thinking about a bit more how we can address this problem. And so from this point on in the presentation, I'm going to be talking to you about how we decided to address this within Green Labs Austria and with our members within Austria. So our labs, like many labs around the world, go through lots of different types of plastic. And so of course, this can be anything from pipette tips, Eppendorf tubes, Falcon tubes. Even a lot of the chemicals that we order come in single-use plastic containers. And so this is problematic, and we wanted to ask, what can we do about this? And so we started researching what we can find out about plastic. And what we quickly realized, well, hold on, back up for a second. We wanted to ask what plastic can be recycled and what plastic can be replaced. And so now when we started looking into that type of plastic, we've quickly realized that not all plastic is created equally. So broadly speaking, plastic is divided into 7 main categories. And these categories are primarily defined about the different chemical properties that pertain to these different types of plastic. And if we look at what plastic can usually be recycled, it's very common that we can recycle 3 main types. And so those types would include PET, which is what a lot of our drinking water bottles are made out of. We have high density polyethylene and also polypropylene. And so these are what we want to look for. If we are using these types of plastics, then theoretically, these are plastics that we could recycle. And so to address that question, we decided to take a look at our ordering list for the year of 2019. So within this list, we would have all of the items that our lab consumed for its regular research activities. And so we were able to get that list and try to compile and break it down into the different materials that we commonly go through. And so once we did that, we found a chart that looks like this. And so to explain this to you, on the y-axis, we have roughly the number of items that we went through in the year 2019 based off of our ordering form. And on the x-axis here, we have the different types of materials. So for example, one of the items that we ordered the most was filter tips, which were made of polypropylene. And the color code here represents a couple different things. First of all, we marked green as plastic materials that we order that theoretically can be recycled. We marked items in blue, such as paper towels and paper tissues, as items that are not plastic but could still be recycled. And finally, in red, we have several different materials that are just a lot more difficult to recycle, either because of cost or in the case of nitrile gloves, because of a nitrile component that makes them very difficult to reuse. And so this was very eye-opening for us, and this encouraged us to keep going further and to think about what would be the next steps. And while this is all good in theory, we can see this from the ordering list, what we really wanted to know is how much do we go through in a week? And so we wanted to go into the lab and actually do our own experiment to find out how much waste we produce. And so to do this, we actually found 12 volunteers who collected all of their waste for an entire week. And once we had all that waste collected, we then sorted through it and divided it into different categories based on the item. And so when we did that, we get a waste group that looks something like this, which is very interesting to us for several different reasons. First of all, down here in the bottom, we can see that we go through a massive amount of gloves. And I think it's a good reminder that we should be conscious about how many gloves we actually use. And while gloves are a very important part of research activities, in a lot of cases, maybe we don't need to be grabbing a fresh pair. However, in a lot of cases, we do need to, but it's just good to think that through. Another thing that became very obvious to us was that we were using some materials that were made of plastic that could easily be replaced by other items. So one example of this would be plastic plate spreaders that we use to spread microbiological cultures onto agar plates. And rather than using one-time use plastic plate spreaders, this was something that we could easily replace with glass plate spreaders that can easily be sterilized before each use. Another great example that we were going through quite a lot of were plastic serological pipettes. And again, this was something that we could easily replace with glass pipettes that can be washed and autoclaved each time we need to use them. And so this is just a good reminder that when we're thinking about how we can deal with our plastic problem in laboratories, it's always good to replace items whenever possible. And while that is good, we also wanted to try to quantify the rest of our waste. And we decided to do that by separating it by weight and trying to determine what proportion of the total waste by weight is made up of different materials. And when we do that, we get a pie chart that tells us a lot of interesting information. First of all, about 10% of our waste by weight is made solely of gloves. About 16.5% of that waste by weight comes completely from paper. And the largest portion of our waste, about 58% or 24 kilograms, comes entirely from plastic. And of that 24 kilograms, about 11 kilograms or 45.8% could be recycled. And so again, after the order list and after seeing this data, we decided to keep following this through and to see if it would be worth trying to recycle this plastic. Now, this data only came from 1 week of collection, and we decided in order to be more producible that we wanted to repeat this process. And so within our own lab, we repeated this process for a total of 4 times and tried to compile all of that data. And so we get 2 interesting figures from this. We'll start with the figure on the right, this donut chart. And this is again showing the amount of plastic waste on average that we produced in 1 week and the proportion that can be recycled in Austria. And this verified what we saw on the previous slide, that we get approximately 24, 26 kilograms of plastic waste, and consistently about half of that waste can be recycled. Now on the left here, this bar chart, we tried to break down some of that waste and get some more information out of it. And so this very top purple bar here is showing the total amount of waste in kilograms per researcher per year. So what this is saying is that on average, 1 researcher in our lab produces approximately 34 kilograms of waste. Now below that purple bar, we try to break down that waste into the various types that would be included there. So of the total waste, polypropylene, which is a plastic that can be recycled, makes approximately 10 kilograms. So each researcher in our group, on average, is producing 10 kilograms of plastic per year. And while that might not sound like a lot, if we try to put that into something that we can imagine a little more readily, this would be the equivalent of approximately 11,000 1 milliliter pipette tips, which I think it's very obvious that that is a massive amount of pipette tips. And we try to go through all these different categories and break that down. And so again, this really encouraged us to keep going with this process. However, we also wanted to expand it beyond our initial laboratory. And so we were able to collaborate with other members of Green Labs Austria who also volunteered to collect all of their waste and then separated it out just like we did. And again, we weighed all of this waste. We tried to put some numbers on it to see if we see a consistent trend across these different laboratories. And we do. And so again, to walk you through this particular graph, on the y-axis now we have kilograms per researcher per year. And then on the x-axis, we have it broken down into the different types of materials. So PP for polypropylene, nitrile and mixed waste representing items that are not plastic. We have PS for polystyrene and PE for polyethylene. And each of these L1, L2, and L3 represents a different laboratory that participated in this study. And each of these laboratories repeated this process 3 to 4 times randomly throughout the year. If we look specifically at polypropylene, we can see a couple of different colors here. The dark blue is representing commonly used polypropylene materials, which would be pipette tips, EPIs, falcon tubes. And the light blue would just represent other items that are made of polypropylene that aren't necessarily the commonly used items. And while this is a lot of information, the big takeaway that we get from looking at this data is that consistently across different laboratories, one of the biggest contributors to waste is polypropylene, which again is a plastic that can be recycled. And so after seeing all of this within our own lab, within other labs that we've been working with, we decided that it was worth our time and effort to develop a recycling pipeline that we can implement within our own labs and that we could supply to other people in case they wanted to do the same in their own labs. So this brings me to the third part of this presentation, which is discussing the implementation of a plastic recycling pipeline. So to do this, we tried to break it down into 3 broad steps for plastic recycling. Step 1 would be the separation of plastic materials. Very often when you're recycling plastic, it's very important that you can separate it in a way that makes it readily recyclable. So in lab materials, we have 2 broad types of plastic. We have, most of it is being made of either polyethylene or polypropylene. So in polyethylene, we have things like needle caps, falcon tube lids. In polypropylene, we have the Eppendorf tubes, pipette tips, the bodies of falcon tubes, etc. And you'll see from this figure that we also need to separate it into autoclaved and non-autoclaved plastic. In almost every biological laboratory, if any waste has been in contact with biological material, it will need to be autoclaved, which is why we need to separate it out. Now, a lot of people point out that autoclaving is an energy-intensive process, and they are absolutely correct. However, we like to remind people that regardless of whether or not you are recycling this plastic, it will need to be autoclaved. And so we're not recommending to add additional autoclaving steps. We're just suggesting that the plastic be separated ahead of time and then autoclaved. Other things to consider other than the autoclaving and the separation of plastic is that, of course, if any of these plastic materials have been in contact with hazardous biological material or toxic materials, it simply cannot be recycled. And this is not something that should be new for any laboratory. Every laboratory has protocols in place on how to deal with any hazardous or toxic materials. And so that should always take priority, and none of those materials should go into the plastic recycling pipeline. And I think that's a very important point to remind people. But in summary, for the first step, it's important to separate the plastic and autoclave it if you need to, if it has been in contact with live cultures. Step 2, after knowing how to separate the plastic, would be collecting the plastic. Important thing we like to tell people is that communication is key. And the idea here is to make sorting as easy and sensible as possible for your fellow lab members. So for our particular group, we tried to come up with some informative labels that would demonstrate what items need to be recycled where. And in our case, this looked something like these, where we have high density polyethylene over here. We're trying to clearly show what can and what cannot go into this recycling container. And for polypropylene, we did the same thing. Now, not every lab is going to use the same visuals, and does not have to be a one-size-fits-all approach. A great example of this from another one of our member labs who started this process is here, where they took our design, the basic concept of our design, but they redid it in order to better communicate with their own lab members because they found that this worked better for them. And so it does not matter how you communicate this, whether it's visually or with words, as long as it's clearly communicated for the people that you are working with. Once you have come up with a good way to communicate this, we then recommend putting those labels onto individual smaller containers and supplying those containers directly on the lab bench of the people working in the lab. By doing this, it makes it very easy for researchers to recycle pipette tips, Eppendorf tubes, etc., as they are going about their day in the lab. At another location in the lab, in a spare corner that you may have, we then suggest to put larger containers where you can then take the smaller containers when they're full, put them into or dump them, empty them into the respective larger containers, which then already has the plastic that can be sent for recycling or autoclaved and then sent for recycling. And so this is a great way that has worked very well for us in order to accomplish this. The final step, and arguably the most important, is the recycling of the plastic. Now, not all municipalities have the option of recycling plastic, and depending on what city you live in, there may or may not be different options on how to do this. But this was a very important concept for us because we wanted to know that if we collect our plastic, is there anyone who will take it? And importantly, we wanted to know what happens to it. Unfortunately, a lot of times when plastic or trash is collected, it's either incinerated or sent to another country to be someone else's problem. We wanted to make sure that that was not happening with our plastic. We wanted it to be recycled. So unfortunately, sometimes that's not always straightforward. So in a lot of municipalities, they may have plastic recycling containers, but if you try to follow where that plastic goes, it's typically sent to another waste company that then has many subcontractors that will take that plastic. And if you try to follow this trail, it becomes often very ambiguous. And people either don't know what happens to the plastic that they are using, or they simply don't want to answer your questions. And while this is unfortunate, there are ways around this, and we highly recommend that you look for organizations, businesses, or companies within your local area that you can collaborate with that would take your plastic. So, an example for us in Vienna, we were able to team up with an organization known as Stabselsammlung für einen guten Zweck, which is a group that collects plastic bottle caps and recycles them while donating the proceeds to sick children in Austria. And we were able to contact them and ask them if they would be willing to also accept the plastic that we collect from our laboratories. And they not only agreed, but they also put us in contact with the facility where they recycle their plastic. And we were able to send two of our members there and confirm that all of the plastic that we recycle does get broken down into small granules and then reused to make new plastic materials. And this is a company known as PreZero, which I believe also exists at least in Germany. And this was very important for us. This really closed the loop for recycling, and we were able to confirm that everything we're doing would lead to the recycling of plastic. And so this can be a challenging part, but with a little effort, I think that almost any larger city within Europe, it should be possible to find at least one organization or business that you would be able to work with. So to give a broad overview of this entire process, we of course recommend that you replace any unnecessary plastic consumables, and then you break this down into 3 steps. First, identifying and separating the plastic. Secondly, collecting the plastic, and finally, making sure it gets recycled responsibly. So to wrap up this entire presentation and give some concluding remarks, I again want to come back to the important point that communication is key. If you're thinking of trying this out in your laboratory, what we would recommend doing is working with a smaller group first. If you can find 2 or 3 people who are willing to give this a try and see how it goes, they will be able to give some feedback on what works and what doesn't. And I think that's an important step before trying to roll it out to a much larger lab group. That's what we tried, and it worked very well to work out some of the kinks. And of course, it's always good to be adaptable. If you identify any areas where you can completely remove plastic, that's always the primary goal. And while this can be a very daunting process, we also try to give as many resources as possible for labs that want to start doing this. And so on our website, www.greenlabsaustria.at, We have a resources tab at the top of our page, and under those resources, we have an entire section devoted just to plastic recycling. And so we try to supply all the information that we have found as we did this process. And importantly, we also have a section for frequently asked questions. And so these are questions that we often get from our own members, and we have tried to compile all of those and put those on the website to make it available for anyone who wants to check it out. With that, that is a quick overview of our plastic recycling pipeline. Of course, if you have any questions at all, you can always email us at info@greenlabsaustria.at. We'll do our best to answer any of your questions. And I have to say a big thank you to all of the core members of Green Labs Austria who have really made this possible. It was a lot of work and research to bring all of this together, and there's no way any one of us could have done it on our own. We'd also like to thank our group leaders for being so supportive of this process and allowing us to implement this within our own labs. Of course, you can always follow us on Twitter for Green Labs Austria. The Cells Network also has a Twitter account now, and so this is a great way that we use to communicate a lot of new information that we get. So we'd love to have you follow us and communicate that way as well. And with that, again, thank you, and we look forward to hearing from you if you have any questions.